So first of all, let's define what a percent is and then jump into that as we get going. So a percent, the first part of our definition is it's a ratio. All right, I'm definitely going to add more here, but I'm going to pause there. What's that tell you? That it is a fraction. Exactly. Okay, the very beginning of this unit, section 6.1, we defined what a ratio was. It was a comparison of two numbers using division, which is a fancy way of saying you got a fraction. Okay? Now remember that a ratio can be expressed in three different ways, right? You can write it as a fraction, you can write it with a colon in the middle, or you can actually put the word 2 in the middle of it. Our story problems, I've tried to mix up each one of those as we've gone through it, so you get used to seeing those as all three forms. Okay? So, but a percent is not just a ratio, it's a specific ratio. It says it's a ratio whose denominator is 100. So it's a specific type of a fraction. All right? The second part of this, I feel like most of us probably know, but I think it's at least important for us to understand the significance of this. The symbol for percent is that symbol. Now, again, I'm not going to beat around the bush. You've all seen a percent symbol before. Like, you know what it is, you know what it means. I'm going to tell you that it's got a pretty significant impact in how you read a number. Okay? So, this is something that you need to be careful of. Like, when it says, give this as a percent, you got to have that symbol on there. And you might say, well, Mr. Hopkins, that's just being picky. No, it's not. There's a huge difference. Okay? If I were to give you the number 60, this is the number 60. There's nothing behind it, it's 60. Whereas if I were to give you 60%, that is not the number 60. What is the number 60%? Well, it's actually a ratio whose denominator is 100. 60% is actually 60 over 100. And the last I checked, 60 divided by 100 is not the same as 60. So when we take our next assessment, and the answer is supposed to be a percent, and you don't write it as a percent, it's wrong. Because the number 60 and the number 60% are two completely different things. Okay? Make sure that if we're writing answers as percentages, we are using a percent symbol. Okay? Another example, what I mean by here. How many blocks in this are shaded? 85. 85 individual blocks are shaded. What percent of the blocks are shaded is 85% of them. Okay? But those two numbers mean different things. 85 are shaded. 85 of 100 are shaded. That's when we start getting into that ratio. All right. So, first example, we have to know our definition of this. If we don't know our definition of a percentage, then you're never going to be able to write a percent as a fraction. So, very first example, 1A through 1D. Write the following percents as fractions in simplest form. So, here's what we're going to begin by doing. We're going to begin by using our definition of a percent to write it as a fraction. Then, if possible, we're going to reduce. Okay? So, what did our definition of percent say? It is a ratio or a fraction whose denominator is 100. So, if I wanted to write 30% or 31% as a fraction, it is 31 over 100. Easy enough. Write it as a fraction, you put it over 100. But here's what else you have to be able to do. You got to be able to reduce it. Okay? Do we have any common factors between 31 and 100? No. There it is. That's reduce. Okay? That's all you got to do. Now, let's take a look at letter B, because letter B's got a little bit more to this. Okay, 60% as a fraction means we're going to put 60 on the top and we're going to put 100 on the bottom. Okay, there it is as a fraction. Is that fraction reduced? No. Okay, and it's not reduced for several different reasons. I'll point out a couple of them. Number one, they're both even. And if they're both even, they're both divisible by 2. Okay, but I'm going to save you some time. I'm not going to begin by dividing by 2. The other thing that jumps out at me is they both end in a 0. And if they both end in a 0, then they're both divisible by 10. Now, there's actually even a bigger number that you wanted to, if you could find it right away. What's the largest number that goes into both 60 and 100? 20. So just like we've done with the equivalent fractions, we're going to divide the top by 20. We're going to divide the bottom by 20. So 60 divided by 20 is 3, and 100 divided by 20 is 5. So 60%, if I wanted to rewrite this as a fraction, is the same as 3/5. Okay? All right, you guys try C and D. Rewrite each of those percentages as a reduced fraction. All right, so for letter C, we're going to take 53% and rewrite this as a fraction over 100. Now, here's another thing. So I walk around. Some people, I guess pencil lead must be expensive. You just did this. That's wrong, ladies and gentlemen. You know why it's wrong? Because this has a percent symbol in it. This is not a percent. You don't want a percent within your fraction. Because holy buckets, you just made your problem way more complicated than what it needed to be. You have an integer number on the top and you have a 100 on the bottom. That's what you're looking for. Okay? If you add a percent at the end of this problem, it's wrong. It's wrong. Like there's a lot of times that people just kind of ignore the percents. 60 is 60. Okay, 0.5 is 0.5. Well, there's a huge difference between 0.5 and 0.5%. 0.5 in my mind is 1/2, 1 out of 2. 0.5% is 1 out of 20. Those are two completely different things. Okay, a percent symbol drastically changes what type of number you're actually talking about. That's why we got to be careful with the percent symbol. Okay? Now, this one here, take your numerator is 45, your denominator is 100. Oh yeah, back here, that can't be reduced. I'll save you the time. This one we know can be, because why? Ends in a 5 and a 0, so they're both divisible by 5. Okay? Again, don't spend a ton of time trying to find the biggest. Find one and then go from there. 45 divided by 5 is 9, and 100 divided by 5 is, do 9 and 20 have any common factors? There you go, that's your reduced answer. Now, here's my question for you. Do you guys know how to check to see if you've actually done this right? Because this is one of the reasons I teach this lesson, even though people are like, percents, it's not a big deal. I find most students don't know how to do this simply on your calculator. Okay? So, some calculators have a percent symbol on them. Don't use them. It's a waste of time. Here's what I want you to do. Type this fraction into your calculator. What do you get? Point, nope. Do the division symbol. I don't want a fraction, I want a decimal. You get 0.31. Okay, type this number into your calculator. 0.6. Type this number into your calculator. 0.53. Type this number into your calculator. Do you guys see any relationship here? They're all these numbers, except they're all those numbers with what? With a decimal point in front of the first number. Now you might say, what's this got to do with anything? Okay? Well, when I take 31 and I divide by 100, we said we get 0.31. Okay? Quick question. What happens when I multiply that by 100? What happens when you multiply any number by 100? You can say you add 2 zeros, but what you're really doing is you're moving the decimal point 2 spots to the right. 31. Take 3 divided by 5. What did we say we got? If I have 0.6 and I move the decimal point 2 spots to the right, what do I get? 60%. If I take 53 divided by 100, I get 0.53. If I move my decimal 2 spots to the right, what do I get? 53. If I take 9 divided by 20 on my calculator, I get 0.45. If I move my decimal point 2 spots to the right, what do I get? 45. There's a strict correlation between the decimal answer your calculator gives you and the percent problem that we actually started with. A lot of students don't understand that's the relationship. Okay, back before standards-based grading, I always had to laugh when I give a test score to students that would be like, can you tell me, is that an A or B? They didn't know how to take a number and change it into a percentage. That's all we're doing here. You're taking a percentage and changing it into a number. You've got to be able to go backwards. You've got to be able to take a number and change it into a percentage. Because when you leave standards-based grading and everything is a percentage problem, you're going to have to know how to do percentages. All right, now, example number 2. I'm going to show these to you in a couple different ways. Okay, I'm going to use one of them as our definition. Okay, and the second way is we're going to show you some calculator's ideas. Okay, so write each of the following fractions as percents. We need our answer to be just like the answers were in, just like the problems were in example number 1. A number with a percent behind it. Now, here is the definition of percent way to do it. What did we say percent was? A ratio whose denominator was, all right, do you have a denominator of 100 in part A? Can you make it 1? Yes. How can you make that denominator 100? By multiplying the bottom by 10. But if I multiply the bottom by 10, what do I have to do to the top? So let's multiply the top and the bottom here each by 10. What's that going to give me on the top? 30. Over, what's that going to give me on the bottom? So this is 30%. That's all you have to do. Get your denominator to be 100, and then whatever your new numerator is, that's your percentage, because that's the definition of a percent, right? It's a ratio whose denominator is 100. So, in the letter B, is my denominator 100? No, can I make it that? By multiplying it by what? 20. But if I'm going to multiply the bottom by 20, what do I need to do? I need to multiply the top by 20. So 2 times 20 is 40 over 100. That makes this 40%. All right, I want you to try that with C and D before I show you the alternative method. 5 by 10, though. I don't get 100. Remember, all 4 of these answers should have a percent sign at the end, because 40 and 40% are 2 different things. So let's take a look at letter C. Do you have a denominator of 100? No. Can you make it 1? Yeah. By multiplying bottom by? By what? 20. By 20. Now, if I multiply the bottom by 20, I have to multiply the top by 20, right? So what's the top going to give me? 160 over 100. So what's my answer? 160%. And now here's where it's going to get a little weird. Like, most of you, if you've ever seen a percent problem, you've seen it somewhere between like 0 and 100, right? Like yesterday, there was a 90% chance of rain. Okay? In this class, we're going to see percents that are over 100. Okay? What does it mean? Well, we're not thinking of this as a probability question. There's a 90% chance that it rains tomorrow. That's a probability question. But you are going to see 160%. Okay? If I were to talk about like the price of gas increase in the last 5 years, it's probably 160%. What in the world does that mean? It means that it's more than doubled in price. Okay? You're often going to see percent problems that are larger than 100. And we actually are going to be taking a look at percent problems once we get through all of this stuff right here. Okay? So percents can be bigger than 100. They can be smaller than 1. They don't need to be probability questions, which are, if I'm doing the probability of something, then I am stuck between 0 and 100%. Nothing can ever have a better probability than 100%. Nothing can have a smaller probability than 0%. But if I'm just talking about in general percent problems, I can have numbers that are larger than 100. Okay? All right. Letter D, do I have a denominator that's 100? No. How do I make it that? Multiply by 5, which means I multiply the top by 5. So my bottom becomes 100, and my top becomes 65. So as a percent, this is 65%. Now, I'll be honest, for those people who know percent, they probably never, ever, ever do it those ways. If I have a calculator, there's a way easier way to do it. But you have to know how to do this. So, here's what I want you to do. Type into your calculator. 3 divided by 10. Sorry, 30. 3 divided by 10 is what? 0.3. Now, multiply that by 100. 30%. Take 2 divided by 5. What do you get? 0.4. Multiply this by 100. What do you get? There's your percentage. Now you might say, what are we doing here? This is nothing other than you're solving a proportion. 2 over 5 equals, you wanted to make this a number over 100, didn't you? Well, what's the fastest way to solve this? That's exactly what you're doing there. 2 divided by 5 times 100. You're solving a proportion, ladies and gentlemen. That's all percents are. Okay, over here, you're really asking this question. 3 over 10 is the same as what over 100? If you multiply by 100 here and you multiply by 100 here, you're doing the same work. 3 divided by 10 times 100. We don't realize that, but that's really what you're doing, is what we've been practicing for the last week. You're solving a proportion. This will not sometimes work. This will always work. So you use your calculator again on the next one. Take 8 divided by 5. You get 1.6. Now if you multiply that by 100, you get 160. Now again, something we're going to talk about, especially as we get more into scientific notation. When you multiply something by 100, what are you actually doing to the decimal point? 2 signs to the right. That's it. You're moving this decimal point 1, 2 times to the right, and you're adding in a 0 if needed. Okay? Moving this decimal point 1, 2 times to the right, adding a 0 if needed. So, this is a really quick and easy way to find a percentage. If I told you that you got, and again, you guys haven't done this because you've never done anything other than standards-based grading, but if I told you that you got a 35 out of 40 on your most recent math test, and you want to know what percent that is that an A, is that a B, is that a C, or is that a D, then take 35 divided by 40. Somebody do that for me. We get what? All right. Then move your decimal point 2 spots to the right. You got 87.5%. That's all you got to do. Okay, take your fraction, change it to a decimal, slide the decimal point 2 spots to the right. You're solving a proportion. I'll be honest, most students that need to know how to calculate grades that are not standards-based grading learn this in middle school. You do the division problem, slide the decimal point 2 spots to the right. That's it. Again, it's a proportion. That's all you got to do. It's just a real quick kind of cheat code on how to change a fraction into a proportion or into a ratio really quickly, whose denominator is always going to be 100. This will come back up later on when we start talking about percent problems. We're going to talk quite a bit about that. All right. Next, we're getting into story problems. And here's what I'm going to tell you about example 3A. This is not found in your textbook. Okay? Your textbook will teach you one way to solve a story problem and one way only. And I'm not against the way they use. We'll actually start talking about that tomorrow. But I also want to give you other things to think about. Like the way they do it fits really nicely in their short, quick story problems. They don't fit nicely into this. Okay? So you're going to hear me say these two ideas or ratios, or sorry, not ratios, two proportions over the next week a lot. I'm going to say one of two things. I'm going to say percent over 100 equals is over of, or I'm going to say percent over 100 is equal to part over whole. Now, the percent over 100 should not come as a surprise to us. This is what we call a percentage problem. It's a ratio whose denominator is 100. Now, what it's equal to is going to depend on what type of problem we have. And here's what I'm going to tell you. If I have a story problem, not an is and a no problem, but an actual story problem, I'm always going to think of this as part over whole. Okay? So, let's take a look at example 3A, and then I'll let you guys do example 3B. So, in a survey of 85 people, okay, 20% of them said they usually eat crackers with soup. How many people in the survey said they usually eat crackers with soup? Now you might say, well, but that's easy. The answer is 20%. I want to know physically how many people. Okay, so let's look at this. We're going to set up a proportion. And out of the 4 spots in the proportion, here's the one thing I can always guarantee. You're going to have a denominator of 100 in every one of them that we're going to do for the next couple of days. I don't care if that denominator is here or here. But with the denominator of 100, the number that's going to go on the top is always the percentage. Okay? What percentage are we getting in this problem? 20%. But remember, we're going to write that as a fraction we're just going to do 20, not 20%. Okay? Now, equals, I'm going to teach this as part over whole. So they're going to give you some other quantity. And your job is to figure out, is it the part or is it the whole? That's going to dictate where it goes. So it's going to depend on the problem. So here's what you got to think about. 85 people. Is 85 people the part? And the part would say there's 85 people who like soup with crackers. Or is 85 the whole, which would represent everyone who's been surveyed? Which one does that mean in this problem? It's the whole. It is everyone who has been surveyed. So the 85 needs to go on the bottom. And my variable then will always go in that third and final spot that I didn't fill in. In this case, it's x. Solve. Go. That's what you guys were assessed on yesterday. Use either of your two methods because your variable is on the top, so you could use one method, or you could use the tried and true cross multiplication method. Now, what's 17 represent? Is that a percent or what is it? People. It's the number of people. We don't want to have a percent symbol at the end of that one. 17 people like this. Now, here's the coolest part about this. It is not going to get much easier to check. Grab your calculators. Take the answer you got and divide it by 85. Because that's what our ratio said, right? Multiply that by 100. 20%. It's not magic, ladies and gentlemen. It's not, oh, Mr. Tompkins set this problem up so it works that way. It always works that way. Always. All right, I want you guys to try example 3B. So question. Grant makes $252 a month, right? Mm-hmm. How much does he spend on rent? 810. Okay. So he only makes $252, but he spends 810. 30% is not. Right. He only makes $252, so how can he spend $810? Right? So is the 810 all of his income or part of his income? Part of it. So where does the part need to go? Hey, ladies and gentlemen, here's something I'm going to point out to you. Again, check to see if an answer is reasonable. What do we know? The $810 is what? What do you pay as in rent? Please tell me how you can only make like $200 and some, which is what some of you have. You can't make $243 or $252 and then turn around and pay $810, can you? Yep. No, let me take this cut by that. All right. So we're going to do percent over 100 equals part over whole. So right away we're going to put our 100 in here. Do we know our percent? Yes, let's plug that in. What's percentage? 30%. Now, here's the big part. And this is what I'm telling you, like, get used to this because this is all we're doing for the next 4 days. How do I set up the second half of this? Well, if you don't set it up right, it's not going to be right. So, is the $810, is it part of his monthly income or is it all of his monthly income? It's part. So where does 810 have to go? It's got to go on the top. Part goes on the top, whole goes on the bottom. All right, now this one you don't have the choice on how to solve it. This one, if you're going to set it up this way, you're going to have to cross multiply. The other one we talked about, you'd have options. So this is going to be 30 times x is equal to 100 times 810. So 30x is equal to, this would be 81,000. But then you've got to divide each side by 30. And x would be 2,700. This would seem reasonable. That's his monthly income. The $810 is the part that he spends. Again, this is a quick, easy double check. Use your calculators here. What's 810 divided by 2,700? 0.3. Multiply that by 100 and you get 30. There's your percentage again. Okay? Always able to double check your answer. But again, and some people will be like, this is, I'm going to kind of refer back to the shading problem, like when it was graphing inequalities. Well, Mr. Tompkins, I'm kind of close because I'm right 50% of the time. That means you're wrong 50% of the time. We know the 100 stuck there. You know where the percent goes. If it's a 50-50 chance, I don't like those odds. We really have to start to look at questions and say, what is this? Is this the part? Is this the whole? What are we doing here? Okay? All right. Your assignment for tonight is page 347. Numbers 1 through 27 odd.